All right, let's dive right into one of the biggest questions out there, something straight out of science fiction that is now tickling the very edges of real physics. Could a black hole actually be a portal to another universe? So, yeah, that's the big question, isn't it? Are these unbelievable cosmic objects just dead ends? Or could they be gateways to somewhere or sometime else entirely? That's the mystery we're going to unpack today. Okay, but before we get into all the really wild, out there stuff, we got to do a quick reality check. You know the popular image, right? This idea of a black hole as a giant, hungry vacuum cleaner just gobbling up stars and planets? Yeah, that's not really how it works. NASA's pretty clear on this one. Their gravity is absolutely immense, but it's also local. I mean, if you could magically swap our sun with a black hole of the exact same mass, we wouldn't get sucked in. Sure, things would get super cold, but Earth would just keep on orbiting. They don't go hunting. You have to get way too close on your own. All right, so to really understand the wild theories, we've got to get the basics down first. We need to separate what we know from what we think might be possible. So what is a black hole really? Well, you take a whole bunch of matter, a huge amount, and you crush it into a space that's unbelievably small. The gravity becomes so powerful that it creates a boundary, the event horizon. And you can think of that as the ultimate point of no return. Once anything crosses it, even light itself, it's not coming back out. And look, these aren't just some weird ideas on a chalkboard. They're real. We've got one right in our own backyard, cosmically speaking. It's a supermassive one called Sagittarius A star, right at the heart of the Milky Way. This is an artist idea of what it looks like, and we can actually see its massive influence on all the stars zipping around it. And honestly, the real facts about them are just as crazy as any sci-fi story. They all spin, and some of them are whipping around at over 1,000 times a second. Can you even imagine? The biggest one we found is 66 times billion times the mass of our sun. That number is just, wow. And that term spaghettification, totally real. It's the legit scientific name for what happens if you get too close. We've even taken pictures of their shadows and heard the ripples they make in space-time when they collide. Okay, so we're getting a pretty good picture of what's happening on the outside of a black hole. But the inside, what's going on past that point of no return? Well, that's where things get really weird and where our science kind of hits a brick wall. You know how on old maps, the map makers would just draw monsters or write, "Here be lions," on the parts they hadn't explored yet? For physicists, that's pretty much what the center of a black hole is. We're heading into totally uncharted territory. Here's the problem. Einstein's big theory, general relativity, it works perfectly, pretty much everywhere else in the universe. But it predicts that at the very center of a black hole, all that matter gets crushed down to a single point with infinite density, a singularity. And whenever you see the word infinity pop up in physics, that's basically a giant red flag. It's the universe telling us, nope, your math is broken here. Try again. So, that breakdown, that error message, that's where the door flies open for all sorts of incredible speculation. And maybe the most famous idea of all to replace that singularity is the wormhole. And what's wild is, this idea also comes from Einstein's own equations. It's this concept of a shortcut, a tunnel through the very fabric of space-time. You know, the kind that could connect two completely different places, or maybe even two different universes. This diagram here is a perfect way to visualize it. So, imagine space-time is this flat sheet of paper. To get from point A to point B, you gotta travel all the way across it. But what if? What if you could just bend the paper and punch a tunnel straight through? That's a wormhole, the ultimate cosmic shortcut. Okay, so if the math says they could exist, where are they? Why aren't we zipping across the galaxy? Well, this is where reality comes crashing in, and it's pretty brutal. For starters, these tunnels would be violently unstable. They'd snap shut in an instant, literally faster than light could get from one end to the other. To prop one open, you'd need something straight out of science fiction called exotic matter that has negative energy, basically anti-gravity. And, well, we've never seen anything like it. There's zero evidence it's real. So it kind of feels like the classic wormhole is a dead end, right? But wait, in just the last few years, a truly mind-bending idea has connected these space-time tunnels to the absolute weirdest part of physics, the quantum world. To get this, we first have to wrap our heads around something called quantum entanglement. You link up two particles, and from that moment on, they're connected. Whatever happens to one instantly affects the other. And I mean instantly, even if they're on opposite sides of the universe. Einstein hated this idea. He famously called it spooky action at a distance because it just seemed impossible. So fast forward to 2013, two physicists, Maldacena and Susskind, they come along and propose something absolutely wild. They summed it up in this crazy simple-looking equation, ER equals EPR. On one side, you have ER, the Einstein-Rosen bridge. That's our wormhole. On the other, you have EPR, the entangled particles. They said, these two things are the same. What they're proposing here is that a wormhole isn't just like quantum entanglement. They're saying a wormhole is quantum entanglement. That geometric tunnel through space and that spooky quantum link, they're just two different languages describing the exact same thing. Whoa. And if that's true, the implications are just staggering. It means that maybe space-time itself, the very geometry of our universe, isn't the fundamental building block we thought it was. Instead, it might just be an illusion, something that emerges from this deeper, weirder layer of quantum connections. Okay, that is a beautiful, mind-blowing idea. Seriously, but let's bring this all back down to Earth. Does this mean we can actually travel through a black hole? So, after all that, can you actually jump into a black hole and come out somewhere else? And the answer, based on everything we know right now, is nope. A pretty clear no. As cool as it sounds, all the science points to them being traps, not tunnels. And here's the quick rundown of why. The black holes we actually see out there in space, they aren't these perfect theoretical wormholes. And even if they were hiding some kind of bridge inside, it would be so unstable, it would collapse on you. You'd never make it through. Plus, we still have that singularity problem where physics just breaks. And even that cool ER equals EPR idea, it describes a connection, sure, but it's not a highway you can drive on. So there you have it. Black holes probably aren't portals to another dimension. But look at where the question has led us, to this incredible idea that the universe itself might be stitched together by these spooky quantum threads. And that leaves us with one last huge question to chew on. If the smooth reality we see is just an illusion built on top of this weird quantum network, what other unbelievable connections are just hiding out there, waiting for us to discover them?